automatically. All right.
There it goes.
Yep. Thank you. Yeah, when I was teaching, I would always forget. So I just had it set up to record automatically, and then I never had to think about it. Apparently, I have to change meeting properties. Okay. Come on, tablet. Oh, great. And my tablet has decided to finally do a Windows. And so while I'm talking about, or while my computer restarts, this is the dynamic Ramsey model. And what we're going to do is we're going to maximize over time this infinite sum. So basically, you know the starting point, and then it goes on forever. According to these, what are they called? Constraints. So a couple problems converting this into a CES model. First and foremost, this is not CES, or into CGE model. This is not CES, so we can't put it into MPSGE. MPSGE uses CES functions. And this is CEIS, intertemporal, constant elasticity of intertemporal. So already that's a problem. One of the problems, CES function cannot be implemented in MPSGE. Other thing that's a problem, this has an infinite number of variables. All right, now my tablet works again, so I can write on a screen. This has an infinite number of variables, and that's a problem. Computers don't like infinity. Let's see here, what else is there? The function yt, so aggregate output, f of kt, is only in terms of capital stock. It'd be much better to have labor in there as well. Like, labor is implicit in this. It's not, it's just not exposed. Come on. Which it would be much better if it was exposed. Then we could do things like add a tax on labor. Okay, and my tablet is almost redone, or almost rebooted. Okay. So are people familiar with this? Have you guys seen something like this before, like a Ramsey model like this?
Yes.
All right. It's always good to ask because hey, all right, my tablet works now. Okay. I feel like an Italian with my hands tied when I don't have my tablet. I just can't communicate. All right. So I think what I'm going to do first, I think I'm going to do the interesting part first, and I'll save the math for later, which kills me because math is the fun part, right? So what I'm going to do is I'm going to show the solution first, and then we can talk about how to get there. And the notes that I have provided right here, do go through and do that. I've left a couple of gaps here and there, but I try to point it out. So if I cover something in not enough detail, that's going to be the place to go. But I'm going to skip right to the end, which is right here. And I'm going to try to do this. What just dinged? Okay. And disturb for an hour. Okay. So here's what I'm going to try to do. Here's the classical statement as an optimization problem. And here's the MPSGE model that we've created. It's probably too small to see. In fact, let me move it here, and I can just zoom in. There we go. Okay, so for MPSGE, we have 3 sectors: output, capital stock, and investment. I feel like capital stock might go to T+1, but that's fine. Oh no, this is T. Commodities, output price, return to capital, capital price, and labor price. Return to capital and labor price are not obvious in this model. So when you're like solving this and you make the Lagrangian, you'll get the output price and the capital price. Those are the Lagrange multipliers. Those are the 2 Lagrange multipliers. They're vectors. But these 2 are not. So we can talk about where those come from in a minute. We're doing a representative agent model, and we are going to introduce a single tax. We can always do more. Just start with 1, because why not? Okay, production function. This one, let's start with here. Let's start with K. So K takes in the returns to capital and investment, and it outputs the next price, the next step. That's this constraint right here. Almost exactly. In fact, you can see the 1 minus delta. So it's related to this constraint. Investment, this kind of makes sense. Investment in 1 year points to capital in the next year. And I should explain this. Mustafa may have seen this. This is how I typically write MPSGE models or CGE models in general. It's just a tree. I give the elasticities here and here, and it's just a tree. And I'll show you how it's implemented in Julia in a second. And the production function, this is just output, like single year. So this is within the same year. This points to the next year. This points to the next year. And this variable, down here. And then the demand function is this. This is just summarizing the consumer income. So at the top are endowments, because endowments are outputs. And at the bottom is the demands, final demands. So it's taking in these things. And I define what QREF, this G is the growth rate, R is the interest rate. So you can kind of see like prices are shrinking, quantities are rising, because these are both smaller than 1. And the interesting one is right here. Where am I? Okay. There we go. Move over on the table. This is the interesting one. And this is interesting because this T plus 1, that represents the last time step. So we are only, our time horizon goes to T. T plus 1 is sort of representing the leftover, the infinite part that's left over. Ramsey models level out. What this AT is doing is it's predicting what that is going to be, and we lock it to this. So it's the last step of investment minus the last step of gross output. And I'll show you how this gets modeled, and I'll talk about it. And we also have initial conditions, which I did not put on this slide, but are in the notes, apparently. Did I just not copy that? Oh, no, it's up above. I just don't know what I'm talking about. It's right there. That was before. Okay, so I want to show this off. Zoom in. Okay, this first thing I have is just a struct that holds all the initial values and sets up all the data. You can ignore that for now. You can see what it's doing. But I want to look at the MPSGE. Okay, so what it does is it takes in the data and then just extracts all the information so I can use it. Nothing too horrible there. Zoom in one more. There we go. Okay, so for the MPSGE model, I set up my tax as a parameter so I can change it later. And set up my sectors, my commodities, my consumer, and an auxiliary variable. All of these have start values that are not at unity. So this QREF is 1 plus the growth rate raised to the whatever time step it is. It's just showing how output is growing over time. And PREF is like prices are shrinking over time. So you're predicting how output grows and prices shrink. And this comes from one of the initial conditions as well. Okay. And then this is just representing the tree that we've just defined. Oh, come on. It doesn't like when I scroll with the side wheel on my mouse. It likes to go both ways. But as you can see, elasticity of transformation is 0. Elasticity of substitution is 1. This is being indexed over all of T. T is the set. I can probably scroll up. T is everything except that last time step, which is the time that we're predicting. And then we have our outputs and 2 inputs. And it matches these exactly. I've used longer names here just so I remember what they are. I don't remember what Y0 is, but I remember what base year output is, base year labor, and the base year rental value. And of course, I put a tax. This is something that you can't do easily in the NLP version. And then I type the rest of them in. Okay, there we go. And then I've typed the rest of them in, including the demands. This one right here is interesting because this one has an auxiliary variable. And if you're unfamiliar with auxiliary variables in MPSGE, essentially what they do is they allow you to have whatever the value of this endowment is be or change with the model. So it makes it, what's the word, endogenous to the model. And this TK depends on how we want the terminal investment to be. I think it's this one by default. It's output by default. So it's just the last investment. Like we're matching these two growth rates, and that predicts the final value of the Ramsey model where it converges to. Because this thing's going to end in a horizontal asymptote, and we're kind of telling it what it is. This was a result. This is one of Tom's old results from, was it 2004? It's only a couple of years ago. Okay. And to actually see it, so this is, if you download this repository, if you clone it, all you have to do is run each of these. And it takes a second. I don't need to run them. I've already run them, but you know, for completeness. Here I'm setting up my data, setting up my time horizon. I can change the number of, I don't want that many years. That might break things. I can change the number of years, the growth rate, the interest rate, the depreciation value, anything I want. You do have to be a little bit careful because there are some assumptions that these satisfy. But within a certain range, it's all right. Hold on a second here. All right. And I've set it up so that here's our model. It prints very long because there's a lot of years, but you can see it's typed in, like at least the Y sector is right.
That's beautiful.
Verify benchmark. Thank goodness it still works. That would have been really very, would have been funny if suddenly it didn't work. Okay, benchmark is satisfied. Let's set a tax starting in year 6. So I just took begin plus 5 and right to the end. So I'm just extracting out after year. Begin is 1, so 1 plus 5 is 6. 6 to the end. Set them all at 0.25. So that little dot does. Then I can solve the model. And it solves. And it did not take very long, as you saw. All right, cool. Now I can make graphs. So I have functions that extract the data, because what you might want to do is do different counterfactuals and like merge them together. So this just returns a data frame, which I then tell to plot. So what is this consumption? What is this right here? Let me go here and down. There it is. It returns 3 values. Okay, close the graph. It returns like a normalized investment, a normalized capital, and a normalized consumption. So that's all it's doing is it's normalizing those 3 things. Wages do the same with wages, believe it or not. And the growth rates do this similar with growth rates, except it's the ratio. It's the percent change from year to year. Okay. Which I can see very easily. So these things plot very quickly. They plot very nice, and they match things that they match the historical results, which is always a positive. It's always bad when things don't match. Okay. So it's a lot of work, believe it or not. Oops, that's not what I wanted to hear. It's a lot of work to go from here to here. So what's the advantage of going from here to here? It makes us feel smart. The big advantage, okay, is that I could take this model. Let me go to the model. And go up to the model. I can say, you know what? I want a tax on labor. There we go. AI filled it in for me. Always love it when AI does that and gets it right. And I can just pop it right here. RA. Sure. Because now when I do my model, right here, it's not going to do anything because the tax starts at 0. That's always useful. But I could also impose. Let's do a similar tax on labor, 25%. Did it not? It did so. What in the heck? Oh, it doesn't really change much. It's gonna, it looks insane, but it's going from 0.999 to 1. Yeah. So things don't change too much, which isn't too surprising. But the point is that it's easy to do. So it's easy to do and then verify. Just to make sure. Okay, good. I didn't break anything too terribly. I didn't like that one. This one looks a little strange to me, but that's fine. All right, so now I should stop and I should ask questions, comments, concerns. Or where do you want to go?
Mitch, let's start out with the terminal conditions for 2080.
Yep.
So originally, yeah, at the beginning of the session, you talked about an infinite time horizon. Now we have a finite time horizon.
Yep.
And so I guess I'm not sure where you're imposing.
Yeah.
I guess what would be the transversality condition or some other condition to make that happen.
So that is the purpose of this right here. So what we're doing, I can point to it in this document because it's easier than rewriting everything. So what we did, it is here. Zoom in. So if we start with a model that looks like this, so basically it's going to infinity. What we can do is we can split it to have a finite part and then an infinite tail. But our constraint gets, how did that still make a noise? Okay. There we go. My computer's still dinging at me for some reason. Sorry. We can split it to a finite and infinite part, and then we get this. We add in this correction term. So if this correction term is actually fixed, then this becomes two separate problems because these two things are independent. They don't share any variables. We can solve them independently, which is neat. And if we fix this value to be the correct value, like what it should be, then whatever we get here will match the answers that we get here. So if we pick the correct number here, or if we pick the correct values here, then we can just solve this and get the same answers as we do here for that time interval, not for the tail, but for that time interval. And the question becomes, what's that value? And it's this, which again, we can't find because it depends on the optimal solution. So if we could find the optimal solution, that'd be great, but in general, we can't. So this is what Tom did. So this paper right here, what we do is we pin that value, the one after the terminal value of the capital return, of the capital, to be, to peg the growth rates. IT over IT minus 1 equals YT over YT minus 1. That's kind of the key insight into splitting that up. All right. I ate lunch before this because it was because I'm going to run later, and apparently it's still in my teeth, which is great.
A totally different question.
Yeah.
Why struct? could you just quickly sort of mention that? And then could you also, my other question is like the part that you just showed, could you show us again in the actual code, the MPSGE part where you have the,
This right here.
yeah.
Yeah.
And so 2 little questions.
Yeah, no, that's great. So the reason I use the struct, or the reason that I'm doing this right here, is because there's a lot of data that goes into this, and I'm going to want to use that data again. So when I'm making my graphs down here, the graphs depend on the time horizon and the base year consumption and the reference quantities. So there's a lot of stuff that I'm going to need again. And let me go up to where the struct is defined. The reference quantities are defined in terms of the growth rate and the time horizon. So I don't want to have to do, like, if I change this, I just want to have to change it in one place.
Yeah.
And they depend on stuff that's already defined. So that's the purpose of the struct.
Okay, that makes sense. Well,
Yeah.
it makes sense why you would save it in some sort of format, you know, right? Like
Yeah.
that you can just, and a struct just is the neatest one, I guess. I don't know that.
Yeah, because I can set up a constructor. So these are just default values. If I just call it empty, it'll just fill in those values.
There you go.
Yeah. And then I can like throw errors and I can define things. And then this just tells it how to create the struct. So this you don't have to know. All you have to do is type those in and everything else is dependent upon those.
Nice.
And then that final YT thing, if I scroll and I scroll and I scroll right here, it's right here. So it's the last time horizon. And then that is the value. So if I look at this and I scroll here, I go like that and I scroll over. Do you see this condition right there? P0K, that is, where is that one? Oh, it's right here. I just don't know how to read.
Begin.
So this one is PK0 because it's starting at the beginning. And this is 0 to T of PL times L. That's right here. So you see it T equals T means that it's taking all of them. It's taking the sum. And then the minus AT is that minus, I called it TK there. I'm copying the GAMS. I also have the GAMS code here. I can show you that as well. The minus TK, this is a, what's it called? An auxiliary variable, which gets pinned to this right here. So this aux constraint tells it this is actually that. In MPSGE and GAMS, let me open this. So this is the GAMS version. This is also on the GitHub. If I scroll down, as you can see, it's set up a little bit differently. The quantity is -1 and it has this rate of TK, but it still has that constraint. The reason for that is because GAMS doesn't allow you to do that. You can't put variables inside of quantities in MPSGE and GAMS, but you can in Julia. So I just put it there. In fact, I could have just done that. Maybe too many parentheses or something. This is perfectly valid code. This would work. The reason that the reason I don't do that is I want to be able to change it if I have different terminal investment options, although I think they're all the same. And B, this way, if I want to fix TK to be a value, like if I want to set this to be a value, I can fix it. So I could fix TK to be whatever, and then the model wouldn't solve because it doesn't make any sense to do that. That's the idea.
Cool.
Showslash Ron, did this explanation, did this separability of the optimization help?
Yeah, so I guess, so you took an infinite horizon optimization problem, split it up into a finite piece and then a piece from T+1 to infinity. Yeah, I've seen things like that before. I guess what I'm wondering, and maybe you alluded to this, that it was a lot of work to go from one one problem to another is
Yeah.
how you convert this optimization problem into something that MPSGE can handle, which would be essentially a lot of nonlinear equations that you're solving. And
Yep.
and so it's got to be something like, getting a lot of first order conditions and coding those into MPSGE.
It comes from here. So basically, once we have the zero profit and income balance, these are implicit. Like we don't actually need these. They are useful to get initial conditions. Yeah, these are coming from the constraints. So there's a couple of things we have to do. Let me scroll up. There we go. So I introduced 4 problems. CEIS can't be implemented MPSGE. So the first thing you want to do is make it be CES. And to make it be CES, you apply a monotonic transformation. So you don't want to mess up the order of preferences. So as long as that thing is always increasing, it's not going to screw up the order. This function, 1 minus theta, I can just replace that with x, plus a constant raised to a power. That's just a root function. So it's always increasing. And so basically, this is the monotonic transformation I apply. And if you do the algebra, it pops up to be that. I will say Tom's document that he typed up does have a lot of typos. So if you read that, be a little bit, verify all the math. That's what I've done here. I've gone through his document and verified all the math, fixed all the mistakes that I could find. And he had one here. He had this derivative wrong. It's not catastrophically bad, but basically the marginal rates of substitution, the thing that actually gives the preferences, are the same between u and u hat. So if you actually do the derivative, sit down, have yourself a little bit of fun, they'll both come out to be this. So that changes it from CEIS to CES, which is cool. And then I scroll, or how do I? And then the second thing we have to do, gross output is only in terms of capital. It'd be much more useful to have this as a constant returns to production with labor. So we do that, and then we justify it by saying that if labor is fixed, it's the same thing. So it goes to a, what is it, returns, decreasing returns, something like that. Words always escape me. And the unit cost function associated with this capital F is this little optimization problem, where AL and AK are given by this, or they're sort of derived from there. And the best thing, if I go down right to here, Shepard's lemma gives us the compensated demands. So the partial derivative of this C with respect to the first price is AL for labor, and with the second price, returns to capital is AK. So when you see this AK thing, that's what it's referring to. It's referring to the compensated demands. And that pops out in the market clearance conditions right here. My microphone or my camera is directly in front of where I'm pointing, but I think I'm pointing to the right ones. Yeah, so most of them pop out directly from the Lagrangian, like the first order conditions. Which is super nice. Super, super nice. And there's also a bunch of initial conditions down there. Yeah, so it's one of those things where it's easier in hindsight than it is when you're slogging through it. But the benefits of the MPSGE model is you're able to introduce taxes on both RK and PT, or RK and PL, labor and capital, return to capital, because those are implicit in the model. And it's better to have them be explicit so you can actually, constrain them and restrict them and tax them and put the tax in different places. So this model, this Ramsey theory type model, is actually being used in the household build for WinDC. Yeah, let me pull it up. Yeah, I'll use this one. I go to GitHub, and I go to the place that it's not, and then I go to the place that it is in WinDC build. I think there are currently some issues with the dynamic model. But if I look at this and I zoom in, you'll be able to see these should look familiar. 1 plus growth rate and 1 plus, I put it to the negative t, they just did 1 over. That's fine. So this household model, the dynamic model for the household, is using the same Ramsey structure. The really annoying thing with dynamic models, of course, is calibration. Because you got to calibrate over the entire time series. So I think this one is currently, I don't think it works currently because we've updated the data and then we got distracted with other projects. So we did not actually finish doing that. I know Drew Schreiber has been itching to get this done now.
So the idea here is you start with some real data in the first year, and then you set up the time horizon, and you want to
you sort of
balance.
You predict what's going to happen over time.
And then that's your sort of like business as usual scenario or something, and then you might tweak some element and say like, okay, this is the difference between what we would have predicted in the standard.
Yep. Yeah. So like creating a perfect dynamic model is hard because if you did this in 2019 and you assumed a constant growth rate for the economy, you'd have some bad news the very next year. Right. But most of the time, that's not a bad assumption. Like most of the time, the growth is fairly steady. There can be ups and downs, but yeah, you need to be able to have the data in order to use the data. In this model, in a Ramsey type model, I've been talking to Ed, and he has other models that are more recursively defined that I'm going to start digging into next.
Yeah, Mitch, I mean, I can see a lot of paths forward here.
Mhm.
You know, EPA and Drew's shop, they have the SAGE model, which is,
Yep.
I believe that's intertemporal. And
Yeah.
I don't know if they've attempted to put it in MPSGE ever, but that's sort of one thing to look at perhaps. But then a lot of us work with recursive dynamic
Mhm.
models, which is probably not as big a leap forward. There's a
Yeah.
lot of ad hoc assumptions on investment
I mean,
and
the same is true here.
but what I'm really trying to get at, I guess, in my modeling is once you get to multi-sector models, and if you want to have different kinds of capital, you want to ensure that your capital investment will actually satisfy an intertemporal zero profit condition.
Yeah.
That's sort of, from a, environmental modeling perspective, a lot of it has to do with investment and with all our, ad hoc assumptions about investment. I'm sure there are lots of times where we create capital that that never returns much to the investor.
Right.
So that's sort of what I'd like to get at. But I mean, jumping from here to there, that there's a lot of steps in between that we want to
Yeah.
try and tackle first.
Yeah, I know Ed has a couple of students that are getting very interested in dynamic models because international trade It's kind of important that it's intertemporal because, I mean, the tariffs that Trump is putting in are going to raise revenues in the short term. And it's interesting to see how that's going to have effects going forward, right? Like, what do the models say? Like, people are going to stop trading with us, right? And then they go down. So it kind of needs to be. So I know Ed has a couple students that are getting more interested in this as well. Yeah, I think a lot of the dynamics, I was talking to Ed about this yesterday, and a lot of the dynamic stuff kind of, it's moved more towards the electricity sector. So probably Eli's postdoc advisor knows quite a bit about this. I think he does this all the time. Because energy, they need to be able to predict demand in the future. And I would bet some of the ad hoc assumptions they have made did not account for data centers. And now they have to adjust their models for huge energy draws from data centers and see how that affects the future. Yeah, I'd really like to get this model implemented at MPSGE, like rebalanced and calibrated, because I really want to see Julia chug. This is a very large model. I would really have to aggregate the sectors down because if I scroll up, what is T? Yeah, there's what, 2017 to 2100? What is that, 83 years over all sectors? That's going to be an interesting thing to try to solve because it's a big model.
Is
And
this
you
one
sort of-
recursive?
This is recursive, like, no, in the sense that it's not solving and then updating values and then solving again. Everything is solved at the exact same time.
Oh, similar to what we just did.
Yeah, no, this is almost the exact same structure as what we just did. In fact, I can scroll down. And here, oh no, that's not the constraint. Here is the constraint, the KT. You even use the same variable. Do not be fooled by this sum. This is not actually a sum. All this is doing in GAMS is saying pull out the last element. So it's saying T such that it's the last element. So it's actually just pulling out the last element. I can zoom in. Sorry, I see people leaning in to try to read it. But this is the exact same constraint that we just had. Exact same horizon fixing.
I guess people, well, literally everyone knows more than me about this on this call, but I wonder about the sort of, could you get the same results with a recursive model as you would get with this sort of intertemporal dynamic model? And then would that make it computationally easier? Like, is there a parallel between the two, and doing it recursively would make it more tractable?
I think there would be different assumptions. Like the short answer is I'm not sure. I'd have to test. But I think the longer answer is that if with a recursive model, I can't do something scrolling up like this, right? So this
You can't
T,
figure out the whole, yeah.
it's feeding into the next year. So they really are sort of like a recursive model would be a single year, a single year, a single year. And the years are actually important going up.
Yeah, they're sort of relying on
Right.
plotting out the entire horizon for the solution of all the years. You could probably match it after the fact,
Yeah.
but that
It's
maybe
something I'd
that's a
like to
bit
play
wonky.
with a smaller model.
Yeah.
Yes, we have something similar done for the Apple model. Like a few years ago, we have a forward-looking version, and we compared that to the recursive dynamics. I mean, a little bit higher, so a little bit higher aggregated than the usual model. And we had a paper on that. Was it the Journal of Economic Modeling? I think 2014 or 15, something like that.
Mhm.
Quite interesting exercise, and especially when doing to calibrate to same reference on the two models.
Mhm.
They're quite interesting things, especially, I mean, like differentiated rate of growth, some that it's be very important because usually for the intertemporal model, the usual Ramsey model, you have a uniform growth rate, but in actual models, we have differentiated growth rate across different sectors. So in order to be able to accommodate that, you need to deviate a little bit from the usual Ramsey model, but with similar ideas. So you have also issue of terminal capital pricing and post-terminal and how to do with that, and issues with investment, but at different sector levels, and also add to that the regional dimension. So there's some complications that can go around the Ramsey model, and it's quite interesting to see how they borrow.
Yeah.
You don't have the title or some specific reference? I just would like to at least have a quick look at the paper.
Yes, I will look into that and get to me to send it over to the group.
Yeah, if you
Be
send it
good.
to me, I don't know if you have access
Yeah.
to chat because it says you're external, but if you just send it to me in email, I can distribute it to everybody.
Yeah, I'll put it in the
Yeah, sure.
Teams.
Yeah,
Sounds interesting.
because I'd love to read it. I'd love to recreate it.
I'll probably read the abstract.
It's one of those things where it's like, I don't have enough to do, sarcastically. I'll do that too.
Studious. This is work.
Mitch, is this the like dynamic model against is the version that you use to replace the we call rebalancing routine?
No, I don't think so. This is like the dynamic household model.
This is
And
only for replication of the outcome of the rebalancing routine.
yeah, it's something like
Is it-
that.
Yeah, okay.
Yeah. Yeah, even like the more I look at this, the more I see the parallels because you see it's very much the same model. It's very interesting. I have to sit down with Drew and pick his brain about it, I think. Yeah. And I should also ask, what do people want to see next time? Like in a month?
Well, let me just throw something out here, Mitch. One of the issues with at least my recursive dynamic model is that the return to capital or the interest rate is endogenous, and it's really unstable as you go through the time steps. And so Dominique van der Mensbrugge, for his envisage model, what he does, I believe it's something like, he'll set the return to capital as fixed, and then the variable that then becomes endogenous is the savings rate or the fraction of income that goes to investment. Whereas I have the reverse. I just have a fixed savings rate, and then the return to capital is endogenous. And I haven't tried Dominique's approach, but I would like to and see if that helps. But the interest rate's a pretty important part of the model, and I don't like it jumping around. And in reality, it doesn't jump around anywhere near what I see in the model. But I was going to ask you about the Ramsey model. So the return to capital is something that you see as an output.
Yeah.
And how does that behave? Yeah.
Yeah. Yeah, the return to capital. Let me grab VS code here. Yeah, that's one of our where is it? Prices. All right. So we've got what am I looking for here? So capital itself decrease. I put a tax in there so it decreases. And if I look at so here it is. So if I impose that tax, it sort of glides up. Let me do one thing here. I don't like how this is looking. Let me rerun this real quick. Yeah, that looks better. So you can see the tax year, the year after the tax, the relative return to capital
Yes,
drops,
rate of
and then it
return.
increases over time. Yeah, included in the model, ready to go. And I can also do like the value of N of
One times one.
RK.
One time.
So you can also just see the raw values.
Yeah, because here the shop
So
is
relatively speaking,
the labor, is it?
Capital. Oh, is it
The taxes on labor.
both? And we
Both.
have both
Mm.
taxes.
I should ask if May and Mustafa have questions.
Oh, so
Yes.
we're wondering the capital price and that in the graph, are there both taxes on capital and labor being changed?
It's just the one on capital. So capital inputs get a 25% tax beginning in year 6.
And what's the default tax on capital?
0.
Okay.
And I can show, let's see if this works. Set them all to 0. Not much happens. Nothing ever changes because it's a benchmark.
Mitch, is the capital price there inclusive of the tax or
Yeah, Yeah.
before the tax is imposed? So it looks like it's going up
Tax or
almost at the rate of your
the tax rate,
Tax.
or less,
Yeah.
little bit less than tax rate. So it's inclusive of the tax rate.
Like this one right here.
plotting.
So if you took out the effect of the tax, the capital price would fall slightly. Is that
Yeah.
right? Yeah, okay,
Yeah.
that makes
5%.
sense. If you're taxing something, you would use less of it.
Right. Yeah, and this code is there. You can play with it. You can look at it and admire it, I guess, from afar if you want to.
Mitch,
Yeah.
Mitch, how do you report the post or post tax
How do I do what?
rate of return? Post tax rate of return.
How do I, can you repeat the whole thing?
How do you report the post tax rate of return? So now you're reporting RK, which is inclusive of tax. Can you report another line for exclusive of tax?
So let me see here. Let me look at this graph real quick. That is this one. I mean, in my mind, this is kind of so I believe that RK is exclusive of tax. Like the tax rate is sitting outside of it and it's affecting the actual price. Does that make sense? Like people aren't like what am I trying to say here? Yeah, I don't know if that's an issue. Because this is like a normalized, this is RK calibrated to labor price.
Yeah,
I don't think.
So the RK is inclusive or exclusive of taxes?
Yeah, I would say it's exclusive because the tax is applied sort of after. Yeah. Like the tax affects the price. Oops, come on. I don't think the tax is included in the price.
Yeah, and maybe probably the effect is because of the normalization from the labor price, indexing to the labor price, and labor price is falling.
So if you index, if you can normalize use the consumption price, that'd be easier to change.
Output price, you mean?
Yeah, I
Like
think this is an issue problem for the indexing.
Yeah. How you normalize it.
That may have an effect.
Like do over P instead of over PL, like normalize with respect to regular price?
Yeah. Let me see.
P for consumption or is
It is out price.
um,
Out price index.
Yeah, output price. I think that's the only one that's consumption, right?
is there?
Because before
is
it's normalized with
consumption
respect to
price?
wage.
Let's see.
I mean, consumption price has got to be P.
Yeah.
P for C, sector C.
Since consumer price index.
Yeah, because output is Y, and let me see what that looks like real quick. Yeah, so it changes. Yeah,
Right.
and it sort of levels out. So eventually they're the same.
Yeah.
Yeah. Was that the reason expected? Yeah.
Yeah.
Some
Right.
normalization
Right.
can happen.
Mm. Change the labor.
Yeah.
Right.
Interesting. Yeah.
Mm.
All right.
Because labor dropped this much.
Yeah.
It makes it more expensive. Yeah.
Yeah, because of the investment decisions.
Yep. I had these graphs set up so they match Tom's initially. Where is his?
Yeah.
I think. Come on. Oh, that's the first one. Oh no. Yeah, this matches that. So apparently I just had a typo. That's my bad.
Yeah.
How did I have a typo? I don't know.
Nice.
Yeah. Yeah.
Looks good.
Yes.
I think I know what I was doing. I think I was messing with it, looking at what different things did, and then forgot to change it back. That's on me.
But I think you
no.
get extra credit, man.
Oh yeah, they get A's. Don't worry about that.
Yeah, at least.
All right. Yeah, why'd I have PL there? Of course it's got to be P because everything is in regards to P. If you're unfamiliar with Julia, these dots just mean do it element wise. So the dot means if you have two vectors like this, it just says just pair them up element wise. All right. I said that a lot while teaching. Just all right. Any other questions? Anything else that I've done wrong here? It's possible.
No,
Well,
let's be
Mitch-
able to replicate it.
Yeah, so Mitch, this will take me at least a few weeks to digest.
Yeah, me too.
I guess one thing you might want to tackle that I think wouldn't be too huge of a leap into the unknown is recursive dynamics. Like you have your, GTAP, no, it's GTAP 9 in Julia.
Yeah.
What would you do if you wanted to make that into a recursive dynamic model? For example, would you put the time index right in the model, or would you let it just loop through as independent solves for each time step?
Yeah, that's an interesting question. Well, I have something to shoot towards for next month. I'll try to do that.
I have a question for all y'all, which was to say, like, I think one of the things that's kind of nice in this structure is, like just sort of pulling off GitHub, running it, and then you can sort of play with it to, change the normalization, whatever you wanted to do, and get a sense of it like that. And I was wondering how that feels for everyone. Is that like something that feels easy to do or annoying, or would it have been easier to do? Would it be easy to do just with like copying and pasting GAMS code, or?
I think GitHub is good to use. I mean, I think it for versioning and just for seems an efficient way.
Yeah, I
Is it-
know I'll let May talk if she wants.
So let the
What
audience.
typically happened with Tom is he would send a zip file, and then about a day later he would send a second zip file with this like the same name or underscore new. And then it was hard to distribute to everybody. So like for example here, let me look at model. I added that tax. And then I took out that PL. Typo. And then I'll push. And now if you've cloned that, all you have to do is pull it down, and that is now fixed for you. So I don't have to send out something that's called new. I like that a lot.
I guess
That's why
I'm just wondering if
That's
the
a feature of
mechanics of
GitHub.
That's
cloning.
neat. Yeah.
Yeah.
I don't know. I just wanted to check if people feel like the mechanics of cloning a repo or a repository is it feels like any obstacle at all. Anyway,
Yeah, if it is, let me know, because then I would provide some sort of like resources or training or point to something that could help you out, because super important. It makes it super nice.
A tutorial might not be bad, especially if I've not used GitHub directly within VS the way you just did.
Oh man, that was
so
slick,
good.
right?
Yeah.
All right, let me show you.
It gets
I
better
used to
too.
just, yeah.
All right, let me show you a couple things. I'll do this really quick. If you have to, it's noon, so if you have to run away, I'm not going to be offended.
You have to
But
install an extension or something? Sure.
no,
GitHub
I think this
extension.
should. Let me look at my extensions. Let me look at Git.
No, we look at both trying to remember.
No, these are the only extensions I have for GitHub. So this is in there by default. You may have to install Git. It will tell you. Like if you don't have it installed, it will tell you. I did this recently on my wife's computer, so I know a little bit more. But yeah, once you have it installed and set up, I can just like click here,
So
and it will
see
show
that
me
I just
exactly
want
this.
to point to the frame on the left, the file sort of thing, the little magnifying glass, and then this third one with the branch thing is the thing that the button to just get into the GitHub part of VS Code.
Yeah, if you click that and it says not installed, you probably click a button and it will tell you how to do it.
Mm.
So VS Code is a Microsoft product and GitHub is a Microsoft product. So they integrate very nicely together. And I have down here, you can switch branches. So I can create a new branch. I could check out a detached. I can sync. It's very nice. It's one of those things where if you play with it for a little bit, it sort of becomes clear. I can also see what's going on in my GitHub graph as well.
And then to clone a repository, sort of start the process online at the GitHub online sort of.
Oh, Eli, no.
No?
Uh,
Out of there.
Now let me pull this real quick.
Just for the URL or whatever, no?
Let me look for, what's this one called? What did I call this? Dynamic? There it is. So what I'm going to do is I'm going to go code. I'm just going to copy that.
This is what I meant. That's what I meant.
Yeah,
That's
okay.
it.
But
I didn't mean anything more extensive than that. Just that step.
I see. Go to clone, but I could probably type here, clone from GitHub. Okay, move that because I can't, I could probably type, there it is.
Don't do that. I guess people, that's your repositories.
No, I think this will work because this isn't mine.
Maybe. All right, maybe.
But if you,
I would just go to I would go to the online and click on where it said clone and copy that.
I think if you type this, it'll be unique enough that you can do that. And then I can put it somewhere and it'll just sort of work.
Where you put it, it's pretty useful too.
The project folder.
Yeah, I think where I would put it is, where is it, Julia?
Yeah.
I'd put it in a place called Dynamic Ramsey, which is exactly where I have it.
Yeah, or Deb or library or something.
Yeah. Wherever you can find it. It's your local computer. You can organize it or disorganize it how you choose.
Maybe at a end of another meeting, spend a little bit more time that doesn't feel like past the deadline, and the step by step
100%.
stuff feels like very just like
100%.
yeah, a nice little move.
Cool. I should stop because people probably have other meetings and other things to do. But if you have any questions or follow-ups, let me know. I'll do my best. It's all we can do is our best, right? So that's what I do.
Great. Thanks a lot, Mitch. Appreciate it.
Yeah,
Yeah,
thanks so
so-
much, Mitch.
Thank you very much.
Oop, there we go. No problem. See you all in like a month.
It's great. Wonderful.
Or next Tuesday.
Take care.
Bye.
Why stop recording? There we go.